So this one is an investigation. I could leave you to do this on your own. I would like you to do the synthetic division on your own. So here you go. Do a synthetic division.
Can I do long division?
It's always long.
Whatever division you do, it's always long. You can has cheeseburger. I don't care.
Okay, thank you.
But if you learn how to do synthetic, it's much easier, right? Now maybe that's right, maybe that's wrong. I don't know. You'll let me know.
You get 0.
Well, it is a remainder of 52.
Oh, it says, did you get a remainder of 52?
Maybe. Yeah. No English.
Yes.
How do you divide by
If not, try again. You should get the sheet up one. It's easier to do whatever kind of division on the sheet.
Doesn't it? No, I'd rather blank. I think it's easier to do it on.
Okay?
Yeah, I think it's easier to do it on. Yeah.
Determine f of 2. So it says determine, which means show your work. So f of 2 is 3 times 2 cubed plus 5 times 2 squared plus 6 times 2 minus 4, which is, what, 24 plus 100
What?
plus, I don't know, what am I doing? Squaring,
100.
maybe 20.
Yeah, not 100.
24 plus 20 plus 12 minus 4, which is 48, 44, 56, 52. Did you get the same value as the remainder? Yes. This is only a coincidence, you say. Let's check with another example. What kind of reasoning are we doing? Inductive reasoning, right? We are trying specific cases. Okay, so we tried a synthetic division and then we substituted in a value and man, they were the same. Go ahead, you do it long.
Okay.
I don't care, divide it, right? How you divide is up to you, but I mean I would do synthetic if I were you.
No, it's okay. The other one has my name in it.
Determine g of negative 3. So note the placeholder for the x squared term, right? So you have to go, if you're looking at this, you're going constant x, x squared, x cubed. That's how you tell. So you don't need this. You could rebuild the, what's the polynomial, right? If I scroll that off, well, okay, it's constant x, x squared. So it's 4x cubed plus 5x minus 7. Okay. So, 2080, negative 108. Are you convinced now?
No. We must do another example.
You say yes, we'll need to do another example.
I say possible.
Okay, so we're going to come up with a conjecture based upon having done 2 examples. When a polynomial f of x is divided by x minus a, then
Negative a substituted.
X equals any number.
Yes, negative.
Actually,
the remainder
always equal. Always the same. Always the same.
Minus.
No, it's just A. It's just A.
Yeah, I told you it's just A.
f of f of a, right? So it's what follows the negative sign.
Because the negative's already negative. It's negative, but the flip side.
Think of it as it's kind of like the root, right? You got a factor and you got root. It's kind of, but it isn't. f of a, yes.
For the second example, it's x plus 3.
Yes.
Yeah.
Yeah, and then we substitute. Yeah. So what's the problem?
So what's the problem?
No English.
Yeah.
No English. That's always a problem.
Yeah.
So I don't
So
want
you're
to
good?
talking about
Yeah.
What's the problem?
Okay.
There's no problem.
When Logan's making fun of you in math, you should be ashamed.
Yeah, it's. Somebody got their phone.
Determine the remainder when x cubed minus 4x squared plus 5x minus 1 is divided by x plus 1 by using synthetic division. You want to do long, just attach a piece of paper to it with all your divisions on it.
Yay. Oh, no. Go short. No, I don't. Prove that I have to. That's a lot. Oh, her, not mine.
Ow!
Okay.
You deserve that for that minus sign.
Why does it have to do it both ways?
Got below, I think you deserve that. Got below 5,000, you deserve that. It's over 9,000%.
Okay.
Where is the minus one?
Let me just pause this one.
Yeah, you can say.
What's p of negative 3?
0.
What's p of negative 1?
Positive, negative.
What's p of 1?
Plus minus 0.
What's p of negative 2?
Plus or minus 0.
No.
Oh, wait, what? Oh,
What's p of 0?
6.
What's p of 2?
Plus or minus 0.
Okay.
Plus or minus.
Use your conjecture and the information above to determine the remainder when p of x is divided by each of the following divisors. So if we divide by x plus 3, what's the remainder?
Zero.
If we divide by x plus 2, what's the remainder?
Negative.
If we divide by x plus 1, what's the remainder?
0.
If we divide by x, what's the remainder?
6.
If we divide by x minus 1, what's the remainder? 0? Okay. I'm trusting you now because I can't see it anymore. If we divide it by x minus 2, what's the remainder?
0.
You should have found that p of negative 3 is equal to 0, since the value of the polynomial function is 0 at x equals negative 3. We say that negative 3 is a 0 of p of x. List all of the zeros of p of x. Negative 3, negative 1, 1, and 2. What degree is that anyways, just out of curiosity? It's of degree 4. So then, what do we know about these divisors?
Their roots.
In the way, I can see it.
I don't know what you're talking about.
You should put a star around them.
Wrong word.
Yeah, they're factors.
They're factors.
No, because there's.
They're
You
not
can get the root.
I can't have.
Right there. Those are the root. Right, those are.
So what do you know about these numbers? They're the roots or the zeros, right? Negative 3, negative 1, 1, 2. So if the divisor has a remainder of 0, then it goes into it, and that makes it a factor of it, right? Just like 3 goes into 27, but 4 doesn't go into 27. So 4 is not a factor of 27, but 3 is.
It goes into 27. Does not.
When 230 is divided by 5, the result is 46 with no remainder. Since there is no remainder, I think I just said something similar to this, but 5 is called a factor of 230. List 4 other factors of 230. 2.
not 3.
1,
2, 4.
20.
1.
No.
13.
13.
Yeah,
13 goes into it.
103. No, I'm just kidding.
123. Say 1. 122.
No, I trolled. So sorrow.
No, you're sorrow?
Why are you guys so
It's 23.
Yeah.
Go.
There should be more. There's 10.
Go with 10 and
There's 10.
you could divide by 10.
Oh yeah. No wait, what?
I'm sorry.
You could do 200.
Just go 1, 230, 2,
Those are prime factors.
and 115.
Yes. Genius.
You go to 79.
It only wants 4 factors, guys.
Yeah, I know, but so we
Prime factors.
overlisted. The prime factorization is only 3, right? It's 2 times 5 times 23. But there are other factors.
Oh, 1.
Examine the table in part B. State the divisors that are factors of P of X. Already did this, right? But what are they?
1. X minus 2.
Okay? State the divisors that are not factors of P of X in that table.
In that table.
I think it was X plus 6.
Minus X plus 2. X plus 3.
Wait. So.
What else is in that table? So X and X plus 2, right?
Oh, excellent.
That's it. You guys looking at the same table I'm looking at?
Yes. No.
Apparently not.
Sorry.
Maybe that's also why we're failing.
Oh.
Yeah. There is a connection between the zeros of a polynomial and the factors of the polynomial function. Examine your answers for part C and E1. Complete the following table. The factor is X plus 3. The 0 is? 0 is? 0 is? 0 is?
2.
Okay?
1.
I get it.
Right?
It's just those signs.
Yeah.
Based on your results, complete the following conjecture. If A is a 0 of f of x, meaning that if f of A is 0, then
That's not sending up X
minus A.
is a factor of fx.
Isn't it
That's not fx.
Okay? So if A is a 0 of f of x, if we know the zeros, then we get the factors. If we know the factors, if x minus A is a factor of f of x, then
Root. Yeah, then the root is. Right? Is that what you think?
Then f of A
Then A is the root.
Oh,
Root
Is
of fx.
X intercept.
X minus 2.
Or actually, it's a 2.
you know what? We'll just call them zeros. No, it's a 0.
Why not the
Oh,
intercept?
It's a 0 of a function. Right? The roots are the roots of an equation. It's the zeros of a function, and it's the x-intercepts of the graph. Okay, so it's a value of x that makes f of x equal to 0. Yes?
How do you make sure it's opposite sign? If it was like x minus 3.
How do you make sure it is?
Yeah, how do you show that A has to be the opposite sign?
What do you mean?
X minus 3, therefore A is 3.
Yeah, exactly.
Okay, x plus 3, therefore it's minus negative 3. Okay.
How do you show? Well, okay, Sam needs to show. Let's see if that answers your question.
Alright.
Combine the above two conjectures to form a biconditional.
I forgot what biconditional means.
If
An if and only if statement.
I forgot what that is.
It's
A
only
is a
if
zero
A
of
is a
fx
zero.
if and only if x minus a is a
Remember,
factor.
Pillin, don't say it again.
A is a 0.
Yeah, I know. I was trolling you.
If
It's a 0.
If and only if.
A minus a is a, or x minus a is a factor.
A minus A is 0. We'll make that right here.
Okay. You could also legitimately have written x minus a is a factor of f of x if and only if a is a 0 of f of x. Doesn't really matter which statement comes
Because
first.
A is 0.
Just don't use it is.
It is a 0.
Pillin.
So a is a 0 of f of x if and only if x minus a is a factor of f of x, which basically just reads as these two statements. Right? So when you see this, you can split it out and read it like this, and you can split it out and read it like that. Sam needs to show that x minus 3 is a factor of p of x equals x cubed minus 2x squared minus 23x plus 60. One way to do this is to divide p of x by x minus 3 and show that the remainder is 0. Another way to show that x minus 3 is a factor of p of x is to substitute 3 into p of x and show that
It also
It also equals 0.
Equals 0 all of it.
and show that p of 3 is equal to 0. Use one of the above methods to show that x minus 3 is a factor of x minus or of p of x. Which one would you like to do?
The second B, because B is easier.
Actually, if you use A,
So p of 3 is 3 cubed
if you use A, it helps you
minus 2 times 3 squared minus 23 times 3 plus 60. 27 minus 18 minus 69 plus 60.
I think
So what can I say then? Since p of 3 is equal to 0,
X minus 3 is a factor of p of x.
x minus 3
Factor of p of x.
is a factor of p of x.
I did something.
Okay. Now that you know x minus 3 is a factor of p of x, completely factor p of x. So now, we're going to have to divide x minus 3 into p of x, which we will do using synthetic division.
I love how you just did that in the first question.
Expecting a remainder of, so we know that's got to be a 0, right?
So 60.
Since you have the 3x anyway,
Meh.
A summary.
Yes, to be 60.
Oh, one quick.
Okay.
that looks like it's 10.
So, I'll give you a moment to catch up.
I already saw that. I'm far.
All right, then p of x is equal to x minus 3 times x squared plus x minus 20, which is
X minus 3, x plus 5, and then x minus 4.
so there's the fully factored form of p of x, which is of degree 3, right? Okay, we don't know, well, we know what p of x expanded is, so we knew it was degree 3. In expanded form, you're going to see a 3. In unexpanded form, you say, okay, multiplicity 1, multiplicity 1, multiplicity 1. Degree is the total of the multiplicities, or those exponents, so it's degree 3. And yeah, is that it? No, yeah, it's completely factored.
Yeah, like 5 years
Since you had to factor p of x anyways, was it better to determine that x minus 3 is a factor using the method of 6a or 6p?
What?
Okay, so here's the thing, right? Let's say we don't know whether something is or isn't a factor. And we want to see if it is a factor. Right? Because there's many factors of 60, right? So we need numbers that are going to multiply to give us a 60 something. So there are many numbers that could give us a 60 at the end, right? So we got negative 3 times 5 times negative 4. So we didn't necessarily know. It could have been a 2 and another 2 and a 15, right? It could have been a plus 2, a minus 2, and a 15. Those could have multiplied to 60. Okay. We don't know. So if we're trying to see if something is a factor, we can either do the division or we can do the substitution. Which one's faster? The substitution. So if we want to check to see if something is a factor, let's do the substitution. If we know something is a factor, then we can do the division because then we know it's going to divide in easily. But if we're trying to say, hey, is 3 a factor? Or sorry, is 3 a root? So that means x minus 3 a factor. Well, okay. Or is negative 3? Like maybe this was positive 3 instead of x. So depends on what you know. If you don't know and you're just trying to see if that number is in fact an integral factor, then use 6b, right? Just look for the remainder. Hey, I'll throw a number in there and see if the remainder is 0. If it is, then I know what the associated factor is, right? I throw a 3 in, p of 3 is 0, x minus 3 is a factor. Okay. So there you go. Yes. Yes. In summary, the remainder theorem. When a polynomial f of x is divided by x minus a,
Oh god, I should pick attention. What?
then the remainder is f of a. This means the remainder can be determined by evaluating the polynomial function at x equals a, which is determining
0.
The right main dot.
Oh, I'm afraid. So sorrow.
likewise. F of a could be determined by finding the
X.
0.
remainder
Okay, yeah, there we go.
when f of x is divided by okay. So you can do a remainder by dividing it, but we can also now do a remainder by substituting in, right? Only works when it's x minus a, not when it's 2x plus 1. If your divisor is 2x plus 1, you want to find the remainder, use long division. Okay? Or stick in negative a half, but use long division. Factor theorem. So that's the remainder theorem, right? It says there's 2 ways to get the remainder. One is by dividing, but that's a pain. We don't like to do that. The other is by substituting in the value of a when the divisor is in the form x minus a. Factor theorem. The binomial x minus a is a factor of a polynomial function if and only if a is a 0 of the polynomial function. In other words, x minus a is a blank factor of a polynomial function f of x if and only if f of a equals 0. So if you evaluate the function for a certain value and you find a 0, then you have found a root. The factor is x minus the root, right? This means that if f of a is equal to 0, then x minus a is a factor of f of x, and that if x minus a is a factor of f of x, then f of a is equal to 0. Congratulations.
Yay!
Oh. We appear to have reached the end of this worksheet.